How do we generate a prediction based on a hypothesis for agricultural research? In the ever-evolving field of agricultural research, the ability to generate predictions based on hypotheses is not just a luxury, it is a necessity. As global challenges such as climate change, food security, and sustainable farming practices loom large, researchers must adopt a systematic approach to formulating hypotheses and deriving predictions that can lead to actionable insights. This article delves into the intricate process of generating predictions from hypotheses in agricultural research, emphasizing the importance of a structured methodology, data collection, statistical analysis, and validation of results. Understanding hypotheses in agricultural research. At the core of any scientific inquiry lies the hypothesis, a testable statement that provides a foundation for research. In agricultural research, hypotheses often stem from observed phenomena or gaps in existing knowledge. For instance, a researcher might hypothesize that a specific crop variety will yield better results under certain soil conditions. This hypothesis serves as a guiding framework for the entire research process. To effectively generate predictions from a hypothesis, it is crucial to ensure that the hypothesis is clear and specific. Vague or overly broad hypotheses can lead to ambiguous predictions that are difficult to test. Researchers should strive to articulate their hypotheses in measurable terms, allowing for the identification of key variables and relationships. This clarity not only aids in designing experiments, but also facilitates communication with stakeholders who may rely on the findings for practical applications. Moreover, researchers should consider the context in which their hypotheses are situated. Agricultural systems are complex and influenced by numerous factors, including environmental conditions, pest pressures, and socioeconomic variables. A well-defined hypothesis should account for these complexities, enabling researchers to formulate predictions that are both realistic and relevant to real-world scenarios. Data collection, the backbone of prediction. Once a hypothesis has been established, the next step is data collection. This phase is critical as the quality and quantity of data directly influence the reliability of predictions. Researchers must employ rigorous methodologies to gather data that accurately reflect the variables outlined in their hypotheses. Field experiments are often at the forefront of agricultural research, allowing scientists to observe crop performance under controlled conditions. However, data collection can also extend beyond experimental plots. Utilizing remote sensing technologies, soil sampling, and agronomic surveys can provide valuable insights into broader trends and patterns. By integrating diverse data sources, researchers can enhance their understanding of the factors affecting agricultural outcomes. Moreover, it is essential to ensure that data collection is systematic and replicable. This involves establishing clear protocols for sampling methods, measurement techniques, and data recording processes. By adhering to standardized practices, researchers can minimize biases and errors that could skew their predictions. Additionally, employing statistical software for data management can streamline the analysis process and facilitate more accurate interpretations. Statistical analysis, turning data into predictions. With a robust data set in hand, researchers can now turn their attention to statistical analysis, a pivotal step in generating predictions from hypotheses. Statistical methods allow researchers to identify relationships between variables and quantify the strength of these relationships. Common techniques include regression analysis, ANOVA analysis of variance, and machine learning algorithms. Regression analysis is particularly useful in agricultural research as it helps determine how changes in one variable, e.g., fertilizer application, impact another, e.g., crop yield. By establishing a predictive model based on historical data, researchers can forecast future outcomes under varying conditions. For instance, if a researcher finds that increased nitrogen levels correlate with higher yields in a specific crop variety, They can predict similar outcomes in future planting seasons. However, it is crucial to approach statistical analysis with caution. Overfitting, a common pitfall where a model becomes too complex, can lead to misleading predictions that do not hold up under new data. Researchers should prioritize simplicity and interpretability in their models while ensuring they adequately capture the underlying relationships present in the data. Validation, ensuring accuracy and reliability. The final step in generating predictions based on hypotheses is validation. This process involves testing the accuracy of predictions against real-world outcomes to ensure their reliability. Validation can take various forms, including cross-validation techniques, where models are tested on separate datasets or through field trials that assess predicted outcomes under actual farming conditions. Furthermore, engaging with farmers and agricultural practitioners during the validation phase is invaluable. Their first-hand experience can provide critical feedback on the practicality of predictions and highlight any discrepancies between theoretical models and real-world applications. By fostering collaboration between researchers and practitioners, agricultural research can become more relevant and impactful. In addition to field validation, researchers should also consider peer review as a means of ensuring credibility. Sharing findings with the scientific community allows for constructive criticism and enhances the overall rigor of the research process. Conclusion: generating predictions based on hypotheses is an essential component of agricultural research that can drive innovation and inform sustainable practices. By understanding the nuances of hypothesis formulation, implementing rigorous data collection methods, employing robust statistical analyses, and validating results against real-world scenarios, researchers can create reliable predictions that contribute to solving pressing agricultural challenges. As we navigate an uncertain future in agriculture, embracing this systematic approach will empower researchers to make informed decisions that benefit both farmers and consumers alike.